I'll check on her.
She's sick.
Uh-oh. All right, guys, here we go. We're very quickly going to go through quadratic functions, okay? Or solving our quadratic equations. I'm going to make this short, sweet, and simple, and you should have some time today to work on homeworks. That many were not complete on Friday the other day. So here we go. Quadratic functions. All right, the first thing I want to remind you is that these coefficients, A, B, and C, they are always paired how you see them. Your A value goes in front of x squared. Your B value is the coefficient of x, and your C value is your constant. Something else that we know about quadratics, okay? This degree right here tells me the total number of solutions that we have for that type of equation. Quadratic equations are my parabolas. So if it were going to hit the x-axis, it could only hit it a maximum of 2 times anyway. Okay? Now, evaluating. Short, sweet, and simple. Okay, if I am evaluating a function, I am simply taking that number and plugging it in. We've been doing this since the very, very beginning of this school year, in addition to here at Perry High School. Okay? If I plug this number in, I type in a -2. Oh, you can't see that, can you? I'm going to do parentheses. And then does everybody see down here by this decimal, there's like a little minus sign with parentheses around it? Hit that for the negative. Don't use the minus button for the negative, okay? All right, then I'm going to do the 2. -2 squared plus 6 times -2 plus 8. And what do I get? 0. Y'all can speak up. So I plugged in -2 and I got out 0. I can write that as an ordered pair, and ordered pairs can be plotted, okay? Where would that ordered pair, where would that point land? On the x-axis, yeah. So this right here ends up being one of my x-intercepts, okay? All right, it says find f of 3. So I would do the same thing, 3 squared plus 6 times 3 plus 8. Let's see, if I go and I type in 3 squared plus 6 times 3, and then I do plus 8, I got f of 3 is 35. So I could write an ordered pair 3, 35, and that would give me another point. Is that an x-intercept? No, definitely not. Okay? All right, and then right here it says find the value or values of x when f of x or y equals 0. This right here is asking me to find my x-intercepts. Now you could type this in Desmos and you can just click on the points where it crosses over. Okay, there's nothing wrong with that. But another way to do this, I can factor. So x plus 4 and x plus 2. If that's set equal to 0, then I end up with 2 solutions. -4 and -2. Okay. You would do the exact same thing for this next one, okay? Remember, when it's asking you to find the values of x, it's asking you to find the x-intercepts, okay? Now, in the past, okay, we have made our main focus for finding our solutions factoring, square root method, and quadratic formula. Those are the algebraic ways. We also have graphing, right? Graphing will make it much easier. But there's one more method that we need to consider, and we'll look at that last today. We're just going to go back through those first three methods, okay? So solving by factoring. We need to make sure that one side of my equation is set equal to 0. Okay, and I'm going to factor the best that I can. What two numbers multiply to give me 12 but add to give me 7? 3 and 4. This is where you take those individual factors, you break them apart and set each one equal to 0 so that you can solve for x. What would my two solutions be here? Good.
Excuse me, I need Juliet Cruz in the office for checkout, please.
Yes, ma'am.
Thank you.
All right, this one right here, this is not set equal to 0, so I'm going to move this 10x backwards, and I'm going to make sure that I have that one side set equal to 0. Okay? Now I have a GCF here. That GCF is 2x, and when I remove that or divide it out, I have x minus 5 left inside parentheses. Okay? So, right here, we would take 2x and set it equal to 0, and we would take x minus 5, and set it equal to 0. What do I multiply by 2 to give me a product of 0? 0. And what do I get when I solve this one for x? Positive 5. Those are my two x-intercepts. All right. I should recognize example 3 as a difference of squares. So that factors into x plus 4, x minus 4. So my solutions here are plus or minus 4, positive 4 and negative 4. You can list them individually, or you can put them together like that. And then on this one, I don't have one side set equal to 0. Does everybody see how this x squared has a negative leading coefficient? I don't like that. So I am going to actually move these two things over to the right-hand side so that I make my x squared term positive. Okay, so this is where we do the x method. I'm going to do 2 times negative 2, and I get negative 4. And my b value is negative 3. What two numbers do I multiply together to get negative 4 and add to get negative 3? Perfect. And then we'll reduce our fractions. You got 2 over negative 4. That's 1 over negative 2. So x minus 2 times 2x plus 1 equals 0. Now, if I set each one of these equal to 0, what would I get for my two solutions? What about this one? Let's start easy. 2. Now, for this one, my first step would be to subtract 1 and then divide by 2. Okay? All right. Square root method. I love square root method. It's short, sweet, and simple. Okay? But we are only going to do square root method. Get off your phones, please. You're only going to do the square root method when you have an x squared and a number. Okay? If I have an x, I'm not going to do this. Don't forget, we got to have a plus or minus with my answer. Okay, got to have that plus or minus with your final answer here. All right, so my job is to solve for x, and currently sitting on top of that x is a square. So I'm going to take the square root of both sides, and I get x equals plus or minus 7. Square root of 49 is 7. It might ask you to list them separately, so you would just write 7 comma negative 7. Done. All right. On this one, my job is to get x all by itself. But that x is currently being protected. So in order to get inside there, you've got to get rid of that square root. Okay? Or sorry, the square. That's going to give me x minus 3 equals plus or minus what? 5, yeah. That's all right. Now, when I isolate my x, I am going to move that, and I'm actually going to stick it in front of the plus or minus. Okay? So this is x equals, that's going to be positive 3 plus or minus 5. And I get two solutions here. I get 3 plus 5, and I get 3 minus 5. So since these are pretty numbers, I actually want to carry those out. 3 plus 5 is 8, and 3 minus 5 is negative 2. Okay? If you type that equation into Desmos exactly like you saw it, it's going to give you those pretty crossings. Okay? Work smarter, not harder, but there are some process questions in your homeworks. Okay, like what would you put inside here? What would you put here? All right? Now, next my job is to get x here all by itself. So I need to work my way from the outside in. We have to move the outside stuff away. So that's going to give me 4 times x minus 5 squared equals negative 100. What happens when I divide both sides by 4? You still got the x minus 5 squared, but what do you get on the right-hand side? Negative 25. Okay? Now remember, I'm trying to get to x. So now I'm going to take the square root of both sides. And I have x minus 5 is equal to plus or minus, because I just took the square root. What will I put behind that plus or minus? 5i. Don't forget there will be an I if you have a negative inside there, okay? And then we're going to take this negative 5 and we're going to move it right here in front of the plus or minus. So there are my two solutions. All right. Next, I'm trying to isolate the x. I'm going to start by dividing by 12. That gives me x equals 5/12. So how am I going to get x by itself? Take the square root. Okay. Square root of 5 over square root of 12. Don't forget our plus or minus out in front. We don't like that radical in the denominator. So we're going to rationalize. Okay. This is where I multiply the top and the bottom by that square root 12. Now, so far, this gives me plus or minus the square root of 60 over 12. Now, I want to take 60 and I want to break it down. Y'all okay with 12 and 5? That's what I just multiplied together to get it. 12 breaks down into 4 and 3. And this 4 breaks down into 2 and 2. So you got a pair of 2's, and then the 3 and the 5, they don't have anything left, or they don't have a buddy to break out with. So right here, I got x equals plus or minus 2 square root 15 over 12. And then we've got these outside numbers right here. The 2 and the 12 become 1 and 6. So final simplified answer, plus or minus square root 15 over 6. Now make sure that you use these as reference, okay? As you're going through and you're doing your practices. I tried to model the problems that you'll see here in your packet. Okay? Quadratic formula. Okay, I used to sing to my Algebra 1 kids. I won't do that to you. But I want to make sure that one side is set equal to 0. And we will do quadratic formula when factoring just simply isn't easy or it's not possible. Okay? All right. We want one side set equal to 0. So I'm going to take this stuff and move it over here with the x squared. So that's x squared plus 2x minus 8 equals 0. And the next thing I want to do is identify my A, B, and C value. I call this my ABC box. What is A? 1, because it's always with x squared. B is 2. And C, which is my constant, negative 8. All right. This is where we need to just get it all set up. Now, I like to call this kind of like the shell of my quadratic formula. I just set it all up with a bunch of parentheses where those variables go. Okay? And I'm going to come drop in my values. All right, this is negative b plus or minus the square root of b squared minus 4a times c all over 2a. Now this right here is where I take what is underneath the square root. Not the square root, but the stuff that's underneath. This is called the discriminant. That is the b squared minus 4ac part, okay? That is the part that is underneath the radical. And that is what I'm going to put in the calculator, okay? So I've got 2 squared minus 4 times a times c. Now, once again, I'm using the minus for minus 4ac. But for my negative numbers, I'm using this negative key, okay? And that gives me the number 36. So this simplifies to negative 2 plus or minus the square root of 36 over 2. What do we know about 36? Perfect square, okay? So let's see. Negative 2 plus or minus 6 over 2. I have two cases here. I have negative 2 plus 6 over 2. And I have negative 2 minus 6 over 2. What's negative 2 plus 6? Just 4? And 4 over 2 simplifies to 2. And negative 2 minus 6 more is negative 8. And negative 8 cut in half is negative 4. Okay? Now, if you had typed this into Desmos exactly like you were given that function, you would have seen the two pretty places where it crosses, okay? All right, this one's already set equal to 0. I'm going to do my ABC box. For ABC, I have 3, 4, 2. I'm going to get the shell of my quadratic formula set up. What am I dropping in here? Okay. Next. There you go. Good job. All right, now I'm putting my discriminant, the stuff underneath the radical, not the radical itself, okay? Because sometimes if they're not pretty perfect squares, I don't want it to give me an ugly decimal, okay? So I got 4 squared minus 4 times 3 times 2. All right, so I got negative 4 plus or minus the square root of negative 8 over 6. All right, the negative is its own thing. What does the negative tell me is going to be in my final answer? An I. Good. All right, but the 8 breaks down into 4 and 2, and that 4 breaks down into 2 and 2. So I get negative 4 plus or minus. I have one group of 2's that I can take one out. I have the I, and then this poor, lonely, leftover 2 goes back to jail. Okay? Now, when I talk about quadratic formula, and I talk about simplifying, okay? I like to think of all these outside numbers, everybody out on the playground. You ever told you had to play with everybody or you couldn't play at all? Yeah. So everybody here has to share something in order to play. Okay? If they don't all share something, I'm going to leave it alone. Okay? Do they all share a common factor that I can divide out? Yes, I can divide out a 2. That leaves me with a negative 2, a 1, and a 3. So my final simplified answer here is negative 2 plus or minus I root 2 all over 3. Okay, I want for you and your seat partner to work through number 3 and number 4, and then let's see if we get the same answers. Now, if I messed up on mine, please tell me. You will not hurt my feelings, okay? Take a few minutes and work on that. All right, check your work with mine. When you put your discriminant underneath that stuff that's underneath this radical, make sure that you put parentheses around that negative 3 If you got 31 underneath your square root, that's because you didn't put the parentheses around, okay? Be careful, because if you write it in the calculator like this, it's only applying that square to the 3, and it's multiplying the 9 times a -1. So it should be a positive 9 there, okay? All right, any questions? All right, last page for the day, okay? Let's talk real quick about completing the square. Now, I'll be honest, this is not my favorite way to solve a quadratic, okay? But it's really not too bad. All right, the goal is to write all of my quadratic stuff as a perfect square trinomial, because I want it to factor into like an x plus or minus something, okay? X plus or minus some number where it's squared. I want to be able to factor it where you've got two things that are the exact same. So here we go. I want to move my constant to the other side. So I'm going to take my constant here, which is -7, and I'm going to scoot it over. Okay? That gives me x squared plus 6x. I'm going to leave a space right here, and then I have this plus 7, that positive 7 on the other side. Okay? Then I'm going to take my b value. Now my b value here is 6. I'm going to cut it in half, and I'm going to square it. What is 6 cut in half? 3. And when I square 3, that gives me 9. Now that number is the number that I'm going to add to both sides of my equation. Now I do it to both sides because if I do something to one side, you have to do it to the other. The golden rule of algebra. Do unto one side as you do unto the other. Okay? Now let's think about the factoring process here. What two numbers multiply to give me 9 and add to give me 6? 3 and 3. So you get x plus 3 and x plus 3. So when you factor this, I can write that as x plus 3 squared. The number that is inside the parentheses, right there, after I cut it in half, that's the number that's going to be inside my parentheses when I factor it. 7 plus 9 is 16. And then I carry it out how I would the square root method. So here, I end up with x plus 3 equals plus or minus 4. And when I'm solving for x, I'm going to stick that number out in the front of that plus or minus. I have -3 plus 4, and I have -3 minus 4. Those are my solutions. -3 plus 4 is 1. And -3 minus 4 more is -7. Those are your two solutions. Now, if you just type that in exactly like you saw it, you were going to get those pretty numbers anyway because they cross over the x-axis. But there are some specific completing the square method questions on your homework 21. Okay? So here we go. Let's do this again. I'm going to take my constant right here on example 3, and I'm going to move it to the other side. So I have x squared plus 4x. I'm going to leave a space, And then I get -8 over there. Okay? This time my b value is 4. So I'm going to take my b value, cut it in half, and I'm going to square it. 4 cut in half is 2, and 2 squared is 4. So I'm going to add 4 to both sides of my equation. Now when I factor this, the two numbers that multiply to give me 4 and add to give me 4 are 2 and 2. Well, that was the number that was in my parentheses. So this factors into x plus 2 and x plus 2. So I'm going to write it as a square. Let's see, and -8 plus 4 is -4. So I'm going to take the square root of both sides. I get x plus 2 equals plus or minus 2i. And then I'm going to subtract 2 from both sides. I got -2 plus or minus 2i. Okay, I want to do one more with you, okay? I want to do example number 2. All right, so right here, I'm starting by taking my constant, which is -4, and I'm going to move that to the other side. Okay? Now, I'm going to take my b value, which here happens to be -3. I'm going to cut it in half and square it. Hey, am I going to get a pretty number when I cut that in half? No. I'm going to leave that as a fraction, and that is going to give me the number 9/4 that I'm going to add to both sides. Okay, I know we don't like fractions, but since I taught you that little trick, when I factor both sides, we should get x minus 3/2 times 2. And when I do 4 plus alpha y equals, and I put this in as a fraction, I get the fraction 25/4 over here on the right-hand side. Now, I like 25 and 4 because when I come in and take the square root, I'm going to have x minus 3/2 equals plus or minus 5/2. And I'm going to move this over. I have x equals positive 3/2 plus or minus 5/2. Okay? Now I have two situations, both of which that denominator remains 2, because when I add fractions, your denominator stays the same. Okay? What is 3 plus 5? 8. And 3 minus 5 is -2. 8 divided by 2 is 4. -2 divided by 2 is -1. Okay? All right. I would like for you to log in and use your remaining 10 minutes to work on, well, 11 minutes to work on your homework. Okay? 19, 20, 21.